Hello and welcome everyone to another live session at the Reactors. My name is Ravneet and I'm the Program Manager at Reactor London. Before we begin, please take a moment to read our Code of Conduct. We're all here to learn, so please be respectful of other people's views, understanding of differences, and please be kind and considerate in the way you engage. The chat will be open throughout and we do encourage you all to participate. Also, this session is being recorded and will be available to view on a Microsoft Reactor's YouTube channel in the next 24 hours. Today, we have with us Scott, who is going to talk all about Flux for Helm users. And with that, I'm now actually going to hand it over to Scott and I'll bring him up on the screen. Hi, Scott.
Hey there, how are you?
Yeah, good, thanks. Handing over to you now. So whenever you're ready, just go right ahead, share your screen.
Okay, great. We'll go ahead and do that now. Give me just a sec.
Yeah, no problem.
Okay, nearly there. Here we go.
Amazing.
All right, can you see my slide?
Yes,
Right.
I have just, yeah, I have. So I'm gonna go off the camera now and I will be in the background. So if you need me, just shout my name.
Okay, great. And in terms of Q&A, just real quick, will you kind of give me a heads up at the end or a voice over if someone requests a question?
Okay. Absolutely. And so if there's any questions, I will show them on the screen. I'll show them on the screen to you. Okay. So once you're almost done with your demo, once you're about to finish, just let me know and I'll come back right up on the screen and we'll do some Q&A together.
Awesome. Thank you so much.
Okay, thanks.
All right. Well, hi, everybody. You came here because you, I think, are here to hear about GitOps for Helm users. I am Scott Rigby. I'm on the developer experience team at Weaveworks. I'm involved in various CNCF things, including co-chairing the CNCF GitOps working group. And I also co-maintain several CNCF projects, including Helm, Flux, and the newer sandbox project, Open GitOps. So I'm giving this talk on using Flux to implement GitOps for Helm users. So here's my Twitter handle, that R6BY Leet style. Yeah, feel free to reach out to me about, about open source projects generally, but about any of this stuff, either on Twitter, on CNCF Flux, or however else you can find me. I'm pretty findable. So just quickly what to expect. I'm going to, in just one sec, clarify the intended audience for this talk. Going to level set by briefly introducing what Helm, GitOps, and Flux are for newcomers. I'll explain some of the benefits of Flux, specifically for Helm users. And add a few notes on comfort levels around migrating from using the Helm CLI, which is how I would say most users still use Helm. Not still, yeah, most users use Helm. Whether that's in event-driven CI or manually using the Helm commands. And migrating from those to GitOps in continuous and progressive delivery. So then finally we'll end with a demo. Basically showing you how Flux makes it easy to do just that. So who is this for? So you might be using Helm CLI by hand or in CI automation, like I was just saying. You might be just getting started with Helm. However long you've been using it, whether it's you've been, if you're a seasoned veteran, or if you just downloaded it right now while you're like, what is this thing? This talk is definitely for you. So feel there's some things coming. So I'm definitely looking forward to following up on any questions that you might have as well. after this talk, or if there's something pressing in between. We'll quickly get into this for new users, and we'll jump after that into the rest, so that this really should be applicable to everyone here. So you're probably watching this, I would think, because you've got some interest in, or at least some curiosity about GitOps or Flux, but I'm not going to assume any specific knowledge. So start with some intros and try to be welcoming so you can all follow along. What is Helm? Real quick. Helm is a widely adopted package manager for finding, sharing, and deploying apps on Kubernetes. So when we're talking about Helm, or in the context of Helm, you're probably going to hear terms like charts, releases, revisions. So just a quick explanation of what those are, so everyone is up to speed on that in general. Similar to apt or yum for Linux, or other package managers, Helm manages packages for Kubernetes, and those are called charts. Charts contain a set of related Kubernetes resource definitions for applications, which can be deployed to a cluster along with any user-specified configs. And that determines how the application is supposed to behave. So the deployed Kubernetes objects and the user-defined configs, those are the Helm values, together are called releases. And a release has revisions that users can roll back to if something's wrong with a later revision. You make a change and it breaks, or you make a change, you don't like it, you can always roll it back. So that's just a brief intro to what those things mean. And for those that don't know, Helm charts exist for most applications that can be run on Kubernetes. There are, around 7,000 charts to choose from on the CNCF Artifact Hub. So check that out. That's at artifacthub.io. And that just gives folks who don't know a sense of what this is and how it relates to Kubernetes. I would guess most of you do know. Okay, so this is something interesting so in order to guide you through the benefits that Flux brings to Helm, I'm going to briefly note some things that are in and out of scope for Helm by design. So Helm is now, and has been for years, ever since v3, a client and an SDK only. That was an important part of the design when moving from Helm 2 to 3. And that is the current version of Helm, and will be for the foreseeable future. For folks that care about history, there used to be an agent running in the Kubernetes cluster. That is no longer part of the scope of Helm at all. And Helm provides an SDK which is used by the CLI, the Helm CLI, but it's also used by other tools, and it's intended to be used by other tools to make the best use of Helm's internal functionality. So here are some things that are designed to be in and out of scope. In scope is Helm supports the CLI and SDK. Flux uses the SDK. Helm does packaging. Helm handles configuration for applications of Kubernetes. What's in scope for Helm CLI is imperative app delivery. Versioning and rollbacks and the other things that I mentioned about Helm and other advanced Helm users know about Helm. What's out of scope are CRD upgrades. So custom resource definitions. I'm just going to assume some knowledge of that with Kubernetes. If anyone doesn't know about that, please just check it out in the docs. That's Kubernetes, since it's API driven. It also allows other applications to define their own resources, other custom resources. So that's what many applications do, including Flux. But so Helm doesn't manage the upgrades of that. It does manage installing them, but not sequential upgrades. So Helm also doesn't manage or structure multiple environments. Usually, you see people using Helm file, perhaps, or other things that might be declarative in some way, or bash scripts in a make file to wrap them or something like that. It's just also worth noting that Helm, out of scope for Helm, is any kind of control loop or retry logic beyond, like just some internals, because it's generally meant for client interaction. So control loop, none of that stuff. Any automated responses, apart from rollback that I mentioned, is also out of scope. And any automated drift detection, and by drift I mean the difference between what you have told Kubernetes you want and what's actually happening on the cluster. There is none of that built into Helm. There is a Helm diff plugin, but that's as close as it gets, and it's not automatic. So quickly, we'll go over the principles, and then I'll mention Flux, and I think the scope of Helm, why I mentioned those things, will make sense quickly here. So briefly, what this is from OpenGitOps.dev. You can follow along there. You can just check this out. You can also look inside of the open-GitOps GitHub org inside of the documents repo for the canonical location of this. This is where the links here link to, and also link to glossary items from there. So GitOps is a set of principles for operating and managing software systems. The principles are derived from modern software operations, but they're also rooted in pre-existing and widely adopted best practices. So this is not coming out of nowhere. The desired state of a GitOps managed system must be declarative, versioned and immutable, pulled automatically, and continuously reconciled. Those are the principles. Or at least those are the headers for the principles. The principles are the one sentence below. So a quick note about what we mean by declarative in principle one. The difference between declarative and imperative. I'm going to guess that most of you know this, but I'll just say it in a sentence just so it's clear. With declarative management, you declare to the system what you want the end state to look like. The system then works to make that a reality and usually reports status on the progress of making the declared status a reality. Over time, the way the system makes the declared state a reality can change without the need for you to declare, either what you declare or the status of the progress to change. So that's declarative, right? Imperative just tells the system what you want to do step by step. Instead of declaring what you want in the end, you say, I want this to happen, then I want that to happen, then depending on what feedback I get, I want the next thing to happen, etc. Okay, so just to level set on that, we all know at least generally what declarative and imperative mean. So principle one is really similar to infrastructure as code, except it applies to apps as well as infrastructure. We get that question a lot, so that's why I'm pointing that out. Principle two is where the Git part of GitOps comes from, that your declared your desired state that's declared needs to be stored in a way that enforces immutability, versioning, and retains a complete version history. That said, any system that fits this criteria can be used. So it doesn't have to be Git. It can be a number of things. For example, Flux supports S3 API compatible storage buckets, like whether that's S3 or Minia or almost any other object storage by other cloud providers, because they can be versioned. Also supports Helm repositories, charts in those as a source because those are versioned. There's an RFC that's far along in progress now for OCI artifacts. So our OCI registries can also be the source. So just to give some context about that. Okay, so principle three is that this is what differentiates GitOps from event-driven CI jobs triggered by changes in Git. So this is what makes GitOps one of the things that makes it very different from traditional CI/CD. Another question we get is, I have my pipeline stored in Git. Does that mean I'm doing GitOps? Well, are the other principles in place, and is, even if even if you have everything declarative, and even if it's versioned in Git, let's just say, if it's being just event-driven, then it's not actually fulfilling the third principle of GitOps. So ultimately, this is where the desired state of your system is pulled in by the system whenever it's needed, without the need to be triggered by you or your team or any specific actions on the source repository. And principle 4 is this is where software agents are always assessing the actual system state, and they're working to bring it closer to your desired state that you defined in version control. So a lot of folks might have already known this, but for those that didn't, this is really what the principles are, and they're actually quite simple by design, and because they're meant to be foundational principles. And please check out the linked glossary items, because those really get into a lot more detail. So okay, so I'm gonna quick intro to the Flux family of projects. So Flux is a CNCF incubating project that is going through the rounds for graduation review now with the TOC, and doing very well. The Flux family of projects are a set of continuous and progressive delivery solutions from Git to Kubernetes, is what we tell people. This includes the Flux CLI. These are the components in general. The Flux CLI, the GitOps toolkit, which is a set of controllers and Go packages, and Flagger, which is the progressive delivery tool built to work with GitOps. So remember those things I said Helm doesn't do by design, what's outside of Helm scope by design? Those I highlighted because Flux picks up where the scope there leaves off. So where Helm is a packaging and release tool, Flux allows for collaborative, declarative, and automated management of complex environments. Yeah, so I had mentioned that Flux uses Helm's SDK, and that's important to note just because it allows Flux to do very flexible and powerful things while maintaining a solid architecture and a low memory footprint in your cluster. We don't shell out to a CLI. We don't even have anything like that running with the Flux tools as agents. They are purely using the SDK. And the other nice thing about that is it means that any improvements that we work on are moved upstream to the Helm SDK, so that obviously if they're accepted and they are, so everybody can benefit from this, not just this tool, but any other tools that use the Helm SDK. Another thing that's noteworthy, I'll just go over these pretty quickly, but these are the benefits. So Flux's Helm controller does manage CRD upgrades, custom resource definition upgrades. So the Helm CLI has support for, I mentioned the initial installation of CRDs that might be required for the other resources that your charts depend on, right? But it doesn't handle upgrades. So normally that's a manual step. For any charts that install apps that update their CRDs every so often or periodically, regularly, etc. So a very common example of that is Cert Manager. For the Helm users out there, you most likely have used or are using the Cert Manager chart. Just know that you don't have to do manual upgrades anymore when you use Flux to manage your Helm releases. Another few quick things about the scope where it picks up is that for low memory, Flux has a built-in concept of what it's called a depends on feature. So that allows you to manage a tree of chart dependencies without having to make large umbrella charts. So this ultimately saves on memory. If you have any other questions about that, I can give you more details on that later. It makes it easy to manage multiple environments, and that's part of its built-in concept. Basically two other benefits, or three rather. Flux is built on controller runtime, so the control loop and retry logic is really out of the box there, and in keeping with how Kubernetes works. So it gives you feedback on how automating your Helm releases is going as that's happening, using one of the components called the Flux notification controller. So, and then really the last thing I wanted to highlight was that this includes automated drift detection as well. So, I'd mentioned before, that's when resources in your cluster diverge from your desired state all in their own, whether it's because something broke, network problems, let's just say, or, there's a bad actor potentially, or a good actor who accidentally pushed something to the wrong environment. That reconciliation happens for you. Okay, so I'm not going to go over all of these right now because that's going to take a little while, but there's really quite a lot to say. I just wanted to highlight just at least one of these, but I'll read them just in short, so we can kind of get on with other things that are super interesting for everyone. Just know that I mentioned that Flux does GitOps for both apps and architect and infrastructure, right? Really, the idea is that once you're set up properly with GitOps, you're just pushing to Git, and then Flux does the rest. It works with your existing toolset, so that's like all of your well-known Git providers like GitHub, GitLab, Bitbucket, etc. I know I'm speaking to Microsoft, so GitHub is what we're really talking about here. But yeah, really any of those. I had mentioned S3 compatible buckets. You can use most object storage for that, including Azure, of course, and all major container registries, and all CI workflow providers as well. That they work together because we're separating CI from CD. Any Kubernetes distribution as well. So the one I wanted to highlight, though, is the multi-tenancy, and how we say it does multi-tenancy and multi-everything. So Flux uses Kubernetes RBAC to support via impersonation, and supports multiple Git repositories. So it's really using Kubernetes RBAC fully here. Multi-cluster infrastructure and apps work out of the box with Cluster API when you connect that with Flux or install it with Flux. Flux can also give you an out-of-cluster experience. So you can use, what I mean by that is you can use one Kubernetes cluster as a management cluster, and you can then use that to manage other clusters. You can also use it to manage things within the same cluster, or even to spin up additional clusters themselves and manage, basically fleets and life cycle of clusters. So good things. How am I doing, by the way, for questions? Anything come up that I missed?
So we have one question from Frank. I can show it on the screen.
Okay.
There you go.
Oh.
It says, does Flux accept fully rendered YAML manifests instead of Helm charts?
Good question. Yes, it does. And in fact, I'm going to, in the next slide, I'm going to lead you over these Flux controllers. I'm just going to introduce them relatively quickly, and I'll show you how the customized controller, the second one in this list, supports plain YAML manifests. It also supports customized specific things like overlays and other advanced customized features. So yeah, that's actually what's supported out of the box when you install Flux right now is plain YAML, the popular formats, plain YAML, customize, and Helm charts. And there's also a Terraform controller, so you can use Terraform as a format for defining what you want to happen in Kubernetes too. I had also mentioned that OCI is in the works. The RFC is merged, implementable, and in progress. So you'll also be able to use OCI as a source. Oh, excuse me, I'm mixing those things. Oh, my bad. Forget the last part that I said. That's true, but that's actually not relevant to your question. Really, the formats are just those, including Terraform. And if other controllers are built, for example, there's an experimental one that Stefan Proden's working on for Q, you can use that as well. So it's meant to be componentized and something that will grow. I hope that helps answer that one. But yeah, this is a good segue, I think.
There you go.
Good segue to just show you just what the overview of these controllers do. So yes, Flux is a set of Kubernetes controllers. And I'm just going to go from left to right here. Starting with the source controller, just kind of like a one-sentence explanation of each of these. So it watches, what source controller does is watches your defined sources where you specify your desired state, like I'd mentioned before. That's where Git and Helm repositories and what I was just mentioning, OCI as coming, those would be sources, and that's where you define your state. Regardless of the format, whether that's YAML, like plain YAML, customized overlays, Helm charts, or other formats, Terraform, for example. And then source controller brings any changes that you make to those manifests in whatever format they are, and it brings those changes into the cluster for other controllers to then act on. So that's what source controller does, and it does one job, and it does it very well. Kind of Unix philosophy-ish is the idea for these. So I'd mentioned about the formats for the desired state. That's cool. The second one is customized controller. So the customized controller is what's used to get your changes from source controller and apply both plain YAML as well as any optional customized overlays to the cluster. So those YAML files, by the way, include Kubernetes resources or any Kubernetes resources, right? But also CRDs that other controllers such as Helm, the Helm controller, rely on to do their job. And I'll show you an example of that when we get to the demo too. But for example, the information that the Helm controller uses for your Helm releases is a CRD that the customized controller uses to apply to the API. If you're doing GitOps fully end-to-end, if you just wanted to install the Helm controller on its own, you could certainly do that. You would then just be imperatively pushing those Helm controller defined resources, custom resources, to the API yourself. But yeah, that's how that works. And just a very quick note on that, on the naming. The reason that the controller responsible for applying plain YAML is called customize is because the customize tool is built into kubectl. So when we built customize support for that tool, it also for free came with applying plain YAML because it just essentially builds in kubectl apply. So the only reason we'd make a separate controller called a plain YAML controller would just be to overcome that confusion, and I might even be a supporter of that. But that's where it stands, and that's why it's like that. So I hope that makes sense. Okay, so then once the Helm repository and the Helm release CRDs that are defined by the Helm controller are applied to the Kube API by customize, right? Or like I said, however you decide to get them there, the Helm controller uses that information to automate managing your Helm releases for you. So this is the main focus of our talk here, but I just wanted to let you know where this was situated. And then in short, the notification controller, yeah, that keeps you posted about how things are going, notifies you of any problem or any divergence that might happen, just in between things when you're not thinking about it, right? And then the image automation controllers, they have a very interesting job. I like to think of these as handling pinning, basically, of versions for containers. So so they write exact image versions back to your Git source. So if your desired state if you decide to have a semver range or other kind of semver constraint string for your to specify your desired state, which is supported. What happens when you use that same design to spin up another cluster, or what happens when scaling up happens, or what happens when disaster recovery needs to happen. So you generally don't want, say, a new cluster that's spun up from that same source to have a different pinned version of that container that may have just come out in the meantime in between your last deployment and that new scaling up, right? So that's what the image automation controllers do, is they're constantly watching your defined container registries and say, hey, there's a new container that matches your desired semver range. Let's go. You told us to automatically update that for you. We're going to do it, but we're going to pin that for you so it's very clear. Yeah, so I'd mentioned that controllers are built on core controller runtime. So the reason I'm mentioning that again right now is that anybody with Kubernetes knowledge can contribute. This is not something that is esoteric. You may argue that controller runtime is a little bit esoteric, but that's just general knowledge that needs to continue to happen in the community. And in fact, we have been field testing some internal curriculum to help people learn about how to use controller runtime from the very basics to the very advanced use of conditions. So stay tuned for that and let us know if you're interested. That would be open source. So okay, so now I'm just going to take a quick look at architecture diagram for you so you can see how the controllers work to manage Helm releases specifically using GitOps. So this is right from the fluxcd.io website. If you look at the components and under Helm, Helm controller, what you're seeing here is there are sources on the right. Yeah, here we go. If you can see my mouse, these are the various sources for Helm repositories, Git repositories, etc. Source controller, as I'd mentioned, brings those in, and so the Kube API knows about them. The delivery controllers, like Helm controller and customized controller, a Terraform controller, and newer ones coming, are they talk with the source controller, and they know that something has been updated. The source controller says, "Hey, there's something relevant to you that has had an update." So then the Helm controller in this case gets that information from the Kube API, and because source controller brings those in as custom resource definitions, and then it uses that information to manage the Helm release lifecycle. It also sends information to the notification controller, so which is always listening, and the notification controller will tell you there are many different ways that you can configure it. Slack is a very popular one, but I mean, there's just a ton of them. Microsoft Teams, for example, can say, hey, or you can get the information that says, hey, this changed, or maybe I don't really care about successes, but I just want to hear when something's wrong. You can get that too. Okay, so ultimately, just the short version of that is that Flux introduces an additional layer of reliability, consistency, observability, auditability to the benefits that you already get using Helm in your CI, using Helm as a binary in your CI. So I have one more slide to mention to note here before the demo, and I'll go through this for a second, and then right before the demo I'll check on questions, and then we'll get to the demo. So just in short, I'm going to show you how to move, just an example of how to move from the Helm CLI to the Helm controller from end to end in a relatively scripted way, but one that's pretty easy to follow along with. And I have a gist that I'll send a link out to for you. So you can follow along that way too, as opposed to just looking on the screen. If you want to actually do this step-by-step alongside me while I'm doing it, feel free to do that too. You should really be able to if you want to. So the main thing is just in order to use the Helm controller, you need to have Helm, or really to use GitOps at all with Helm, you need to have Helm defined declaratively somehow. Excuse me. And so for Helm CI automation users, this is the process of decoupling your CI from your CD. In quote-unquote traditional CI/CD workflows, they are relatively tightly coupled often. And so we want to make sure to extract that. And for all Helm users, if you're using Flux or when you use Flux, the Helm releases are already properly separated into continuous delivery. So you get that already, that separation already. So I just wanted to notice or note that the people that are listening, you've come because you're interested, because you know that change is necessary or at least valuable. Otherwise, you probably wouldn't be bothering to listen to a talk on GitOps and Helm. But for a lot of people, change can definitely be very scary, right? Especially in organizations where it's taken a while for managers and tech leads and tech directors and all of a sudden, or excuse me, and anyone else to get behind the technology that you already have, your CI/CD systems in Helm. So there are some tips that we also have that we can talk about later. I'm not going to spend a lot of time on this here, but to convince whoever you need to the value of separating your CI from CD. And there's good resources in addition to what I'm about to show you, and more resources on how Flux can help you do that, but in general, why it's a good thing to do. And why you need to do that for, why that's very important to do that for GitOps. So it's really good to note that there are a variety of companies. I know this is a Microsoft meetup here. So big companies, small companies, very, I don't want to say stodgy, but very conservative, older companies, and new companies. They're all adopting GitOps. And there are success stories we can point to that you can help to make your point. And just, allowing them to share the risk with you, it's just much easier to take ownership of this. So there is one note that you can defer to experts to help make your case as well. I do work for Weaveworks, but you don't have to go to Weaveworks to get your questions answered. You can, but if you go to the fluxcd.io website, there is a link under the support page that says my employer needs additional help. And anyone, you're going to see Hold Mirrors here for a second because I'm going to send a chat link, but anyone can, any company can add themselves there. So if you do provide Flux support, open a PR and the Flux team will add you. It's vendor neutral. So great. Before we get into the demo, just going to check questions. Let's see here.
Yeah, there's one more question which says, could I write a custom controller for code that spits out Kubernetes manifests?
Yeah, and in fact, there's a really good. I think what you're talking about is manifest generation, and there's a really good. I'm just going to link to it real fast. Oh dear. Manifest generation. Yeah, there we go. There's a whole. So this one is with GitHub Actions. This is with Jenkins and so on. But there's a whole list of resources for Flux specifically on manifest generation. And I believe that would apply with any GitOps tool you're using, at least well, no, that's not true, but it would apply with many GitOps tools that you might want to use. Here's the link. And so what I believe you're talking about is storing your charts in a different format, right? Like a Python script or something else, and then making sure that that gets moved into some other format, whether that's plain YAMLs or let's just say you've got a complex way of building values for a Helm chart with Python or something like that. You can certainly do that in the CI. That would be part of the CI stage. And then the CD stage would be listening for those changes where those sources are held. It could be in the same repo, different repo, etc. And it would just go as I had noted in that diagram. I want to make one note, though, that you don't have to use manifest generation for everything, but you definitely can, use it as part of your workflow. So Python, for example, doesn't have, as far as I know, built-in support for as a format for Kubernetes manifests. But if you got some structure, or maybe some Python tool that you like that does that, then this is a perfect example of how to do it. If, on the other hand, you have other formats, like I had said, a Helm chart is a format really for deduplicating YAML and some other things. Customize is another tool for doing that. That's very popular. Q has become a tool that's very popular for that. That's a different format. And like I said, Terraform as well. If you are using those types of formats and you want to, then that is when building a custom controller or collaborating with other people in the community on a controller for that format would come in really handy. So please reach out in the Flux channel, like in Slack, or reach out to me, or really any of the other maintainers, and if you have ideas for that or thoughts, because some work on that, on whatever you want done, might already be in process. I hope that helps answer that one. Were there any other quick ones before I wanted to?
No, there's no more questions.
Okay, great. So what I'm going to do then is I'm going to stop sharing my screen so that I can show you this gist and my terminal side by side, because I need to share my whole desktop to do that. Give me just a sec. In the meantime, I'll pass you the link to this demo gist, kind of how I like to do things for myself. Here it is. And quick, just manage my windows, one moment. Okay. Great. All right, let me share my whole screen now. And you should be able to now see a gist on one side that says GitOps for Helm users, and then a terminal on the other side. Do you see that?
Yeah, all good.
All right, great. If anybody wants me to blow up the font, just let me know, and then if you can just voice over and tell me, I can do it. It's fairly easy. But if this is readable, I'll go ahead. Okay, so there's some steps. Oh, also, what's our time check? Just so I know.
So we have about 15 minutes left.
Okay. Okay, great. I will try to be like pretty non-verbose about this, and if folks have questions about it, just put them in the chat, and I'll make sure to leave a little bit of time for afterwards.
Amazing, thanks, Scott.
Sure. Okay, so in short, this is not the only way to install Flux. I'm just doing this for my demo. This is assuming folks have something that they can use Homebrew with, whether it's Mac OS or maybe you use Brew on Linux. And I will not get into the holy war on that one. But this just is just short intro on how to do it. I've already done that locally, so you can see my versions match. Oh, I need to update my gist. Anyway, I have the most recent versions. My gist does not. So you want to make sure to have a personal access token because we're using, I'm using GitHub as the Git source in this demo. So just know that if you want to know how to do this, it's in the fluxcd.io installation instructions, but you just need to select repo scope, and that's really it. In order to do this securely, there's several different ways to do it. I went ahead and exported this. Well, I didn't export it yet. I silently read the token that I had created into my session. So I'm going to just export it. And then you can see, I'm going to echo with no new lines. And that should be, I'm going to count the characters. It should be 40. Oops. There we go. That's what I expect from a GitHub token, right? Depending on what source type you're using, this may differ. Okay, so you don't have to set this. You can just not set it, and then when you use Flux Bootstrap command, it will just prompt you for that, and you can paste that in, and that's a secure prompt. It doesn't show up in plain text, but I'm just doing this for ease of use because I'm going to be using the Flux create command more than once, or the Bootstrap command more than once. I've already created a kind cluster, as you can see right here. It only takes about, 40 seconds, so not really a big deal. But I wanted to show you doing this from scratch, so this wasn't set up entirely as a baking show. I want to make sure to demystify this entirely. So we've got, I'm going to paste it in, and then I'll explain what I'm doing while it takes the minute or so to bootstrap Flux. So what I'm doing is, just to explain this command a little bit, the bootstrap command does a number of things that are all shown on the screen, exactly what's happening. So there's no mystical experience here. Because I said let's bootstrap a GitHub source, it will create a GitHub repo if one did not already exist. But it is idempotent, so you can do this multiple times. It really over and over, and it doesn't really matter if the source exists. It will simply recognize it and make sure to set up the deploy keys properly. And how it does that, just a note on security, is that you don't have to worry about, I said, give a personal access token repo scope. Flux doesn't use that in the cluster. Just in case anybody's starting to bite their nails and wonder, why would anyone do this? We definitely don't do that. It's it's very secure. You can check out the security audit as well, and this is covered as part of it. But just to put your mind at ease, this GitHub, this personal access token does not leave your session. It's really only used to properly create a GitHub deploy token for that repo, and then make sure to create the appropriate corresponding secret in your cluster that has access, that your controllers have access to. So, and that's so that you can access a private repo. You would not need to do that if I didn't say I wanted it to be private, this personal. So you can see here, well, I'll just go ahead and go along with this. Sorry, I'll show you in a second. Another couple things that are important is that normally you wouldn't set the interval to 10 seconds. I'm doing that for demo purposes, so you're not annoyed waiting. And I don't have to fire off reconciliation commands manually. I gave it a path, and I put a note here that's saying, like how to know how you can structure your repo, what path to give it. That is something that we have an entire talk on. You can check out the one that Pinky and I just gave, Pinky Ravi and I just gave on how to structure your Git repositories for GitOps. For now, it's just, in general, there is no one way to do it. It depends on your org, but there are some things to consider, and in that talk, you'll find them. So what I am going to do is I'm going to go ahead and now clone this locally. It made the Git repository, it created the deploy tokens, and it bootstrapped the Flux components into the cluster. I'm I just want to note that any GitOps tool is going to have some concept of bootstrap if it's following the GitOps principles, because there are agents running inside of your runtime environment, which in this case is your Kubernetes cluster or a Kubernetes cluster. And in order for those agents to pull your source, they have to actually be running in the cluster. So you have to have some way of bootstrapping them in. And that's what this does. But one thing that is important to note is let me actually just open up. Well, hey, since this is a Microsoft meetup, let me open up VS Code. It created all the components that Flux needs to run. So once you actually set this up, right now Flux components are running in our kind cluster, and they are reading their own manifests now from this source. So you can actually, if Flux were to have an update 5 minutes from now, and you wanted to test that update, you could change that version inside of your manifests themselves. Inside of the Flux manifest themselves, and Flux would update itself. So that is pretty cool. I'm just going to go ahead and hide this. Oops. Go ahead and quit VS Code. Okay, so excuse me. This is generally what it looks like. Here. All right. Quick time check is okay. So I'm going to create a Helm release with a CLI, just the normal way. You don't have to use the Helm CLI for Flux, as I said, but I'm going to simulate migrating an existing Helm release into GitOps using Flux. So I'm going to go ahead and just use this demo Helm chart. Since I added a repo, I'm going to show values just to show you which ones I can set. Really, you see that here. So I'll keep the screen simple. And I'm going to use the Helm install command, or rather Helm upgrade dash install to install it in the cluster like normal if you weren't using GitOps at all. Okay, so if I do a Helm LSA, you've got that going. Okay, great. So now I'm just going to quickly show you how to convert those to declarative custom resources that Flux understands. So first of all, I'm going to use the Flux version of that same Helm command to create a Helm repository custom resource inside of the cluster, so that the software agents, the controllers running in the cluster, have access to release information. But I'm not going to create it in the cluster. I'm just creating a file. So this file, it really looks like this. We're not going to push it to the cluster yet. I'm just creating the file. Next, I'm going to create a Helm release custom resource. To do that, just to show you a slightly more complex example, I'm going to get the values that I had already set with that Helm command, and they look like this. Just the ones that I used the set command with. And then I'm going to use the Flux create Helm release command. That creates the Helm release custom resource. And it's really very similar to what I just created before for the repos, but it's just for the release itself. Multiple releases can use a repo. That's why they're separated. And then they look like this. Okay. Yeah, ultimately, so you can see that the source ref is actually a pointer to the Helm repository CRD we created. This is a semver constraint, and those values you can see are embedded inside of the YAML here, inside of this custom resource. Those ones we just exported. So now I don't even need my values anymore. I'll remove them. Let's go ahead and add what we just created. So all right. So now I'm going to just go ahead and do a git push. I'm not going to do anything else in my cluster. I'm just going to check it out. If you want to, let's see, we can take a look at watch Helm LS. Okay, so it already has the second revision, and that's because the Helm controller added labels to your Helm release. Excuse me, yeah, to your Helm. Sorry, to this deployment that's managed by your Helm release. So you can see that it's got the Flux cd.io Helm component toolkit labels. Okay, so that just shows you that worked. So I see that you believe me. You may be slightly skeptical. I'm going to show you now just doing a GitOps version of changing that. Changing one of the values just in the custom resource or the custom resource file locally. Pushing it through Git. In fact, before I do, let me give you a visual that this was read as I said it would be. Oops. Start. Is that 8080? There we go. Pod info has the red background like I gave it in the Helm release. Now I'm going to do a git commit, a git push, and then I'm going to port forward that again, so you can see that oops. Oh, I'm going to port forward that again when it's not in the middle of reconciling, and you can see that there's it has changed the background color. We did that just with just through Git, not through any other means, not through the Helm CLI, and not through any other imperative commands. So there we go. We don't have much time left. I think as a time check, you only have 2 more minutes left.
Yeah, right? we do have 2 more minutes, and I think we have 2 more questions.
That's great. Yeah, let's get into the questions. The rest of this demo are just showing you other little features that you can do, like pause and resume for this cluster, and how you can clean up and then show a disaster recovery, like just delete the cluster, recreate it, and your release is there. So I don't think I need to, I have to use these 2 minutes for that. Let me get to the questions.
Okay, awesome. So the question, it's actually quite long. It says, our current CI involves, so it's questions in 2 parts, involves build Docker image and push to ACR, build and push Helm chart to ACR, part 1 or 2. Then, and CD involves pull Helm chart from ACR and apply it to the AKS cluster. So where the change comes when we're going to introduce Flux in the process?
Yeah, so that's a good question. Generally with GitOps, what happens is it's pull based instead of push based, so it's always watching your excuse me, your container registry for where your CI will still build the image. That part shouldn't change at all. Yeah, CD really generally isn't meant to do things like building and testing images. You could do that live with progressive delivery, the testing part. And that corresponds with, and that fits right in with GitOps on the progressive delivery side, as that's attached to continuous delivery. And that's what the Flagger project does. So you can have real traffic decide how you want blue, green, or canary, or any of those things to happen. But yeah, otherwise, no, the image building and pushing and testing, that's all still generally CI. CD is just the actual delivery of that to your environments. And one quick note about that, though, is that while I said that GitOps, in principle, is pull-based, and it must be, there's nothing stopping you from emitting a web notification, like a ping, to the source controller and say, hey, I just updated something in my cluster. So instead of waiting 5 minutes or 1 minute or whatever your desired interval is normally, that's always looking, you can also send another, like Flux supports webhooks. So it can have that exact same reaction that feels pull-based. It's equally fast. Excuse me, push-based. It's equally fast, but it's not really event-driven. It can just be, you can emit an event that says, hey, check again in between your normal reconciliation. If that helps, I hope that clarifies that.
Great. I don't think we have any more questions. So I guess that's it.
Okay, great. Yeah, you may have caught a glimpse of the top portion of a GIF over here that that has Barney's face on it. Don't be alarmed, that's just the cleanup game for cleaning up your cluster. And below that is, if you want to play with this at home, which I think you might, you should be able to follow along exactly what I wrote in the gist. You can show deleting your kind cluster and then just recreating it from scratch, just making that bootstrap command one more time, and all of your Helm releases, in this case one in the demo, but say if you had hundreds or thousands of them, you can see how that would be extremely beneficial to be able to manage that with GitOps.
Great. Thank you. Oh, sorry, just when I was going to say bye, we had another question. Can we have any kind of approvals before change applying?
Yes. So Flux has workflows for that out of the box. And generally that's when you manage, oh, yes. I believe the link to the gist was shared. But,
yeah, I'm going to do it now. Yes.
Yeah, we can do it again. Thank you. Yeah, so yes, Abhi, gates, that's a very common workflow. And it's something like you'd have your main branch being watched by your source controller, for example, and then you'd make sure to set up branch protection so that only just like you would do otherwise, so that only specific approvers can approve those pull requests before they get pulled in. In fact, you can also do that with the image automation controllers I mentioned before. It can work automatically based on your rules, but you can also have image automation make that change not in the main branch, but in a branch that then gets opened as a pull request, so that you can then approve pinned updates. But that's really up to you.
Amazing. Thank you very much, Scott, for your time. And I guess that's it. And we shall see you sometime soon, back again with maybe another exciting topic.
Absolutely. Yeah. Always happy to collaborate and always happy to talk, just like the other people on the team that I work on are. So,
okay.
Yeah, thank you for having me.
No problem. Thank you very much, Scott. Thanks. And thanks everyone for joining. And we shall see you, I don't know, maybe tomorrow for another event.